out the guy behind Kobe Bryant. Oh, my. Was he knuckle deep there?
I hope. Oh, gosh.
And Kobe, of course, tweeting, with the 13th pick, had to dig ourselves out of that one. Ew.
Ew, yucky. Hey, Dirk Nowitzki, mic'd up.
Somebody make some noise in this joint, yeah!
It's the first. It's all a matter of comfort. I think we might need a new microphone. That one wasn't taken off rather delicately.
We should charge him for that.
Mike Green and Jeff Van Gundy calling Dirk.
Take that with you! At number 8, Alexander Noren in the Dubai Desert Classic somehow finds the only trees in the desert. This is you, Linda.
Oh, it is. Yeah, this is Dwayne Evans of St. Louis with a steal, and he's in all alone, but he lost it. And who's laughing now? His teammates. On the ice, Andy McDonald of the Blues. Open net, staring right. Oh. Blues won the game, though, so we'll forget about that.
Brazilian soccer defender clearing a sure goal off the line and then fallbacks into the net, bringing it all down. You see, this is why we can't have nice things.
Way to bring the house down. Two guys, wrong place, wrong time. NBA Kyle O'Quinn. Right off of Andre Blatch's face. That's a painful facial.
Oh, my goodness.
Blatch would be fine. Oh, well, when the swelling went down, he'd be fine. Then from college hoops, Vermont, Albany. Brian Vogel. Running out of time, tries to bounce it off Blake Metcalf, the defender.
Oh, no!
A little too high or too low.
Charles Barkley, live, local, and late breaking.
For Thursday.
Here you go. Look at this.
7-2. Phil Mickelson, you better shoot a good round that day.
This is looking just like your scorecard down here. See, 72, 72.
Well, that's what I shot on the front side.
You did?
Yeah.
No,
I'm not very good.
No, terrible.
Sir Charles looking good. Russian basketball. The coach gets the pass, and he swings it to the player for three. Nice going, coach. I don't think anyone saw that. No basket. One more time.
Niet. Providence against Marquette. There was a bat in the Bradley Center, and watch Sadiki Johnson. It's like my grandmama gave me this chain.
You think? Maybe not.
Those things, they will hurt you.
I'd be doing that, hiding behind any.
Those bats are rabid.
Oh, yeah. Cover your head. Number 1, pregame at Western Illinois. Watch the cheerleader. I know you do that all the time. Yeah, Rocky and the cheerleader. And Rocky, you know what happens? He has to punish himself with push-ups and sit-ups.
She Lou Thez pressed the mascot.
No peripheral vision for Rocky. But is it worse than this?
No.
The infamous butt fumble. You know the star of this.
All right, we're going to get started today. Again, I hope that you're having a great Friday. Right now, Coach Johnson is obviously not there with you, but that does not necessarily mean that I'm not there with you in spirit. So again, as we go through today, you could watch this podcast. Again, I try to put something fun in it to get started. Don't want to make this too long. And so when I do it, all I ask is that you kind of follow me along here, and we'll get started for today, all right? All right, today we're going to talk about simplifying rational expressions. I love this. It's probably one of my favorite things in math. I know I say that a lot, but I love this because it's kind of like a puzzle, something that you could try to figure out in order to try to simplify down. Again, if I simplify something and I put it in simplest form, that means that I'm trying to get the expression, the rational expression, in the simplest form possible. We're not trying to graph. We're not trying to find holes necessarily. All we're trying to do is we're trying to state the restriction, and we're getting it in simplest form. Let me show you what I mean. If I were to factor out the top, by the way, the first step that you always have to do, number one thing you always have to do is factor. I'd get that in your notes, okay? Factoring is the number one thing you need to do before you do anything else within the problem, okay? Number 2 is state the restriction, okay? State restrictions, all right? Step number 3, yep, you got it. Now we got to get it in a simple form, okay? Simplified form, all right? So those are the 3 basic steps. Again, it varies a little bit depending on the problem, but you'll see how pretty easy it is, all right? Let's take it again. Up on top, number 3 on the homework. B squared minus 1 over B minus 1. First thing, is I got to look to see if I could factor. Well, can I factor b squared minus 1? The answer is yes. Now, if it was plus 1, I could not. But because it's b squared minus 1, I can factor. So what I'll have is b minus 1 and b plus 1 on the top. So I factored that out right there. Okay? So step number 1, as I'm looking at it, okay, I check off step number 1 is factor. Factored on the top. Okay? Step number 2 is we have to state restrictions. The same thing as number 2. Okay? When we state restrictions, same thing as restrictions, just going to write it down here, is POD. What is my point of discontinuity? That's all it is. Okay? You find the point of discontinuity. What makes the bottom equal to 0? Well, there's only one number that I could plug into b to make that equal to 0, and the answer is b equals 1. So what does that mean? If I state a restriction, that means that out of all of this, b cannot be equal to 1. Because if it was, 0 would be on the bottom, and if 0 is on the bottom, man, that's just plain wrong, dude. Plain wrong. Okay, it's like kissing your sister. Actually, it's worse than that. It's like, what would it be like? It's like Ohio beating Michigan. Okay, it just doesn't happen, and just flat out, it's just weird. Okay, it's just not good. So then I've stated my restriction right there. Okay, then I'm going to come to it, and then I'm going to cross cancel whatever's on top and bottom. So b minus 1s are gone because it's on top and bottom, and I'm left with b plus 1. That will be my answer. Okay, so again, is it in simplified form? The answer is absolutely yes. Therefore, I've done all 3 steps. Okay, so step 1, factor. Step 2, do the POD. And when you do POD, just state that b cannot be equal to 1. That's a restriction. And then simplified form just is the simple form there. Okay? So again, I could plug anything to b, just anything but 1. Because if I plugged into 1, the bottom would be equal to 0. Okay? Now, I want you to pause the podcast right now. And I want you to try number 6. All right? Just try it. Try to do it as simple as possible as far as factoring, stating the restrictions, and then get it a simplified form. Now, once you pause me, and you're probably pausing me now, and that's fine, but as you do it, try it, and then if you totally don't get it, then come back, and then I'll start, okay? I'll give you about 2 seconds to pause me. 1, 2, and let's get started, all right? Hopefully you're unpaused me by this point. We're going to do the same thing. Step number 1, we're going to factor. So again, my question, on the top, okay? What 2 numbers can add to be equal to 8, but multiply to be equal to 16? Again, this goes right back into a couple units we had about factoring. So it's stuff that we should know. Well, we know we started off with x, and we know 2 numbers that multiplied will equal 16 that add to be equal to 8. You should get positive 4 and positive 4. 4 times 4 is 16. 4 plus 4 is 8. Okay, so 4 and 4 should be the 2 numbers that I multiply to equal 16 but add to be equal to 8. Now I do the same thing on the bottom because it's a trinomial, just like up on top. Has 3 terms. We're going to do the same thing, meaning we're going to have 2 numbers that multiply that equal negative 24, but when added equal negative 2. Well, I'm thinking about it, and I know that negative 6 and positive 4 fulfilled that factoring on the bottom. So I look at it, all right, I factored out, step number 1 is done. All right, step number 2 I come to, all right, let me get a different colored pen. Step number 2 is I state the restrictions. What is my POD? What makes the bottom equal to 0? Meaning those 2 factors, what can I plug into x to make that equal to 0? My answers are x is equal to positive 6, because if I plug 6 in for here, 6 minus 6 is 0, right? So again, x equals 6 is my first one. The second one would be negative 4, because if I plug negative 4 in for x, it would also make the bottom equal to 0. So what does that mean? If I'm stating a restriction, the difference between POD and restriction is we say that x cannot be equal to 6 and negative 4, okay? Hopefully you're following me here. Step number 3 is we just simply factor it. So I've got x plus 4 times x plus 4 over x minus 6 over x plus 4. Is there something on top and bottom that's the same? I feel like I'm on Blue's Clues. You know that guy's like asks a question and then wait for everybody to respond? That's kind of how I feel right now. Just saying. I know it's kind of random, but anyway. So as I look at it, is there something that's the same? Hopefully you're saying yes. Should be x plus 4 and x plus 4. Is there anything else? Answer is no. So I've got x plus 4 over x minus 6. That should be my answer. Now, if you took it and said, oh, but can I cross off x's right here because they're on top and bottom? That is no good. Don't do that, okay? No good. Please do not. Because if you do, okay, that will be incorrect. In order to cross off an x, it has to be on all four terms there, okay? And it's not, so keep it as x plus 4 over x minus 6 as your answer, okay? Number 2. Hopefully, again, you're following me. Same steps. Here's the difference. We're going to multiply now, okay? Multiply. Now, not very hard. Really is not. Same basic steps. I'm going to go through them just like I would on the previous one, okay? Step number 1. I look at it and I say, all right, can I factor it? Well, I can't factor 4x squared, 7y, 12x to the 4th, or 5y. So factoring is already done, okay? I can't factor any further. But here's the next thing we have to do. Instead of doing restriction second, we're going to multiply now, okay? So that's number 2. So all we're doing is adding a step at number 2 and then scooting everything else down. So now what I've got is this. If I multiply, I'm just going to combine what's on top and combine what's on the bottom. So what do I mean by that? Well, I'll end up having 4x squared, 7y, all over 5y, 12x to the 4th. Well, if I'm doing that, I can multiply this out. 4 times 7 is 28, and then I have 28x squared y. On the bottom, 5 times 12 is 60, 60y, x to the 4th. Again, I'm just combining it and multiplying like I would normally do, okay? So now, what do I do now? Well, we go to number 3, which is the restriction part, okay? That's, again, step number 3. What can I not plug into the bottom to make that equal to 0? Well, if I plugged 0 in for y, couldn't I, if I looked at that, couldn't y not be equal to 0? Well, yeah, that would be a POD. Because if we ended up putting 0 in for y, that would make that a restriction. So y equals 0, and then look at x. Remember, too, x can't be equal to 0 because if it was, it would make the bottom as well equal to 0. So also x equals 0 is also another POD. So then we cancel there. So our restriction is y cannot be equal to 0, and x cannot be equal to 0. All right? Next one. Then I look at the bottom, and I say this, all right? I know y can't be equal to 0, and x can't be equal to 0. So now let's simplify what I just circled in purple. So I've got 28 x squared y all over 60 y x to the 4th. Now here's the question. If I've got a y on top and bottom, y to the first on top and bottom, that's the same, and I bring this y to the top, it'll end up turning into y to the negative first, which would cancel. So I cancel on top and bottom. Now, here's the next thing. If I've got x squared on top and x to the 4th on the bottom, can't I bring x squared to the bottom? But if I do, don't I change the sign? So instead of x squared being brought to the bottom, it'll be x to the negative second. Well, what's x to the 4th times x to the negative second? Well, we add those exponents, getting us, and I know I'm putting it over on this side, but let me put it right over on this side. I'll have 28 over 60 x squared. Well, what's 28 divided by 60? Well, again, I'm just reducing now. If I divide both of them by, say, 4, I'll get 7 on top, and I'll end up getting 15 on the bottom with the x squared. My simplified form is 7 over 15 x squared. Notice this, I always want my variables to be positive. So if you got something that's negative, you can make it positive by either changing it to the top or the bottom depending on where that variable is, okay? So again, if I had a x to the negative second up on top in my answer, I could bring it to the bottom, and that would equal 1 over x squared, and that, again, I could bring that to the bottom to make it positive, all right? Again, here's the time to pause it. I've got a couple minutes left. I'll probably put the second podcast below it with the dividing. Totally fine. I'm okay with that. I'll, again, spend a couple more minutes on that dividing, which won't take long at all. But again, right now I want you to try number 10, and I'll do it in just a second. Again, pause me. We'll go from there, okay? Give you 2 seconds to pause me. 1, 2. All right, here we go. Again, I hope you think this is a POC because I think it is, all right? I really do. All right, start with number 1, which is factoring. If I factor the top, I would factor out a 2 right up in here. So I'll have 2 parentheses x plus 6. Okay? On the bottom, right in this part, I could factor out a 3. So I have 3 parentheses x minus 9. Again, I keep the multiplication. On this second one over here, I take out a 2 because that's in common as well. And then also on the bottom, I could take out, well, I look at it. I don't think I could take out anything because I can't take out a 3. So I just leave it as 3x plus 8. Okay, so that's step number 1. Step number 2 says this. We're going to multiply. Multiply is what we're doing. So we're going to have just, again, if I'm looking at it, I'm going to take what's on top, and the bell's about ready to ring here, so don't just ignore that. It's not your bell. It's the bell that's coming through here. If I multiply that, I just combine it. So I have 2 parentheses x plus 6 times 2 x minus 3. Okay, that's all over 3 x minus 9, and then I'm going to put the next one in parentheses just to keep it consistent, times 3x plus 8. All right, and I'm going to erase this on the bottom here. Hopefully it comes here. It's on the bottom. All right, erase this on the bottom. So as I look at it, I can simplify this by taking 2 times 2, which would end up being 4. Okay, and I can't really multiply anything on the bottom because if I did, I would get something that I really did not need. All right, so now I look at it. Number 3, restrictions, or my POD. Well, what can I make this equal to 0? Well, if I plugged in just x minus 9, if I plugged x in, what could I plug in to make that part equal to 0? Well, x would be equal to 9, because 9 minus 9 is 0. Second part is tricky, because 3x plus 8, I can't just figure that out. So all I do is take 3x plus 8, set that equal to 0. Okay, now we're solving. Subtract 8. And I get 3x equals negative 8. Divide by 3, divide by 3. X equals negative 8 over 3. So now I've got negative 8 thirds and 9. Remember, x cannot equal 9 or negative 8 over 3. Okay? Now my last step, hopefully you're getting that down because I'm going to erase this right here. My last step is just going to be solving. Okay? Is going to be solving. So I look on top and bottom and say, all right, is there anything that I can simplify? Is there anything that I can get rid of? With the 4 x plus 6, x minus 3, all over 3 x minus 9 times 3x plus 8, I look at it, and as you see, I don't know about you, but there's nothing I can simplify. There's nothing that I can cancel out. So all I do is take it, x plus 6, and x minus 3, all over 3, x minus 9, and 3x plus 8. I take it, circle it, and now you're good to go. Okay? Again, there's nothing I can simplify that would cancel on top and bottom. Again, to cancel on top and bottom, it has to be the exact same. Again, not much different from what we've done with simplified form. The only difference is multiplying. You got to add that extra step in going across and then proceeding from there, all right? Oh, you know what? Actually, you're probably saying, Coach, what are you doing? Yeah, I messed up because when I factored out a 3 up here, should have been x minus 3. Okay, actually, if I change that, now I've got simplified form. There we go. That's a little bit better, all right? But everything else should be the same. Anyway, I hope that helps. And I'll come back in just a little while to do dividing, and you can see it on the bottom of the podcast. Have a great day, and miss y'all.